Hi friends, welcome to Cracku's video series. I'm Sayali. I'm one of the co-founders of Cracku and an alumna of IIM Ahmedabad. In today's video, we are going to continue discussing what sets we expect to see in CAT 2019. So in the first part of this video's series, we discussed the two sets that we expect to come in CAT 2019. One is on Venn diagrams, one is on set theory. So please do watch the first part before you come to this. So now that two sets we definitely expect to come are Venn diagram and set theory. The third most expected set is of 2D space LRs. So let's take a look at what are 2D space LRs and how to solve questions based on them. Okay, so so what exactly is a 2D space LR? So it's an LR set which requires you to visualize a two-dimensional space. Generally a n into n grid or a square is given. So basically something like say a chessboard or a wire frame or anything of that sort. So you are given like something say 4 into 4 kind of this or 6 into 6 kind of a table where there are different grids, there are different squares within the table, and you have to essentially firstly draw out the configuration to figure out how to solve the question. The thing that is being tested here is visual reasoning. These questions have come in both slots in 2017 and 18. I feel that they are slightly intentional why they have set it. So I feel that they are intentionally looking for a broader understanding of reasoning. They are not just looking for logical reasoning, they are also thinking of visual reasoning or the ability to spatially reason things out. So given that, I expect a set from this kind of LR set to come in CAT 2019, and I'll just briefly explain how to solve these kind of sets. See, in this kind of sets, first thing that you do is you read the instruction set, then you go and see the questions. It's important to see the questions because you need to know how many boards you have to draw. If each question requires you to draw a board, that is 4 boards, it is going to take a lot of time. You might skip this one for later because it will then take over 15 minutes to draw this. What I expect generally is that 2 questions will be based on one board, and the second set of questions will be based on another slightly modified set board. So you should, if there are more than 2 boards as such to draw, you should rethink whether or not you should attempt this set. First, see what boards you have to draw. Again, how to draw the boards also depends on what questions are asked. For example, there was this question set in a recent CAT where the heights of towers were given, and you had to calculate it from how many squares could you reach a particular square. In that case, the board you had to draw is the number of for each square you had to write down the number of squares from which this square was accessible. So what you have to draw also depends on the questions that are asked. So first read the question set, then go and see the questions that are asked, and that will determine firstly how many boards you have to draw and what kind of board you have to draw. So do that. These are generally I feel that the chances of error in these kind of LR sets is lesser because if you are careful, you won't generally make a mistake in these kind of sets. So I personally feel if there are 2 boards and you have time, please go and solve these kind of questions. This is a good set as such to attempt. The general setup would be either a chessboard or a grid or a topographical map. Topographical map basically says that what is the height of different elements with respect to this. So the square above has a height of 3 feet, the square next to it has a height of 4 feet, etc. So all of these are essentially giving you a rectangular or a square board with squares of different attributes essentially. So the only thing you have to do is see the questions, see what kind of information you need to answer those questions, and based on that start drawing your grids. Okay, so let's take a look at a question based on 2D space LRs. Let's take a look at an LR set based on it. So consider the following LR set. 6 ants P, Q, R, S, T, E and U are sitting on a 6 into 6 board as given below. Their positions are pointed in the figure below. After a few seconds, they move 2 centimeters from their position, such that they always move in a straight line along the sides. It is also known that they never change the direction while moving. Following information is known about their initial position. Ant U and ant S are 5 centimeters away from each other. Distance of ant T from ant U and ant S are integers such that ant T is nearer to ant S as compared to ant U. After the movement, each ant will remain inside the board after the movement. Ant U, ant T and ant P are in a straight line. Distance between ant T and ant P is equal to the distance between ant P and ant U. Only 2 ants are at the border of the 6x6 board and Q is one among them. Ant R moved opposite to the direction of ant Q. Paths of no 2 ants will cross each other or will reach the same point. No ant will occupy the previous position of any other ant. So this is the information given. Let me actually take a look at the questions before I start. Okay. What is the distance between ant U and ant Q after the movement of the ants? The next question is, which of the following pairs will lie in a horizontal line after the movement? What is the distance between ant R and ant T after the movement? So that is the basic, this one I missed. What is the ratio of the distances between ants S and T and ants U and R after movement? So basically, what do I need to find out in this set? I need to find out what are the initial positions and what is the final positions. If I find out those 2 boards, I will be able to answer all the given questions. Essentially, this is kind of a puzzle, because here you have to find out which of these 6 refers to which of P, Q, R, S, T, U. So we have to identify which of these 6 points is P, Q, R, S, T and U, and we have to do that using the clues that are given. So the first thing that we have to do is find out what is the initial board and what is the final board. Okay, what is given about the initial board? I'll actually start drawing this so that I can then draw the final table. Okay, so there are 6 squares, okay. So the grid is made, okay, and I'll draw the positions and I have to figure out which of these are going where. Okay. Okay, fine. So now I have the drawing. Now I have to figure out the initial positions of each of them. So what information I have? Ant U and ant S are 5 cm away from each other. Okay, ant U and ant S are 5 cm away from each other, which like suppose I will number these so that it's easier for me to figure that out. Say this is 1, 2, 3, 4, 5, 6. So let's say what is one distance between 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. I need not calculate each distance. If I realize it is not 5, I will just give up. We essentially need to find out how many pairs are such that they are 5 centimeters away from each other. Okay, so this is 2, 3, 2, 4, 2, 5, 2, 6, 3, 4, 3, 5, and 3, 6. Then you have 4, 5, and 4, 6. And 5, 6. These are all the pairs and we have to figure out the distances between them. What is the distance between 1, 2? So that is 3 centimeters. 1, 3, 2, 1, 4. That is something which would be square root 5 plus 25 plus 4, so it would be some root 29. 1, 5 would be 9 plus 4 root 13. 1, 6 would be 3 plus 4. So that is 9 plus 16, so this would be 5 actually. So I found one. 2, 3 would be again not 5. 2, 4 would be not 5, it would be like 2 root 2. 2, 5 would be also not 5. 2, 6 would be 1, 2, 3, 4. 4 it would be. 3, 4 would be 5. So this is important. So I got another one which is 5 centimeters away. And 3, 5 would be not 5. 3, 6 also would not be 5, not 5. This is 9 plus 4, so root 13. 4, 5 would be how much? That would be 9 plus 1, so that's root 10. 4, 6 would be 2 root 2. 5, 6 would be just root 2. Okay, so I found 2 distances which are 5 centimeters away from it. So U and S could be either 1 and 6 and 3 or 3 and 4. Now what else is given about the initial position? Distance of ant T from ant U and ant S are integers such that ant T is nearer to ant S as compared to ant U. Now suppose these are 1 and 6. So do you have any point which is integral distance away from both 1 and 6? Yes, we have 2 which is both integral distance away from 1 and 6. So this is 3, this is 4. So STU can be 1, 2 and 6. So this can be T. and S can be one of these two as such, and U can be the other one. So this is possible over here. Is there any other combination where a point is integral distance away? 3 is integral distance away from 1 but not from 6. 4 is integral distance away from no one. 5 is integral distance away from no one. With 1 and 6 there is only 2 which is an integral distance away from 1 and 6. So one of the options that we have for U, S, T in no particular order is 1, 2, 6. Okay. Now the second one is for 3, 4 and 3 and 4. Now we have to figure out if there is any point which is integral distance away from both 3 and 4. 1 is the integral distance away from 3, but this is not an integer. This is 4 plus 25, so root 29. So that is not an integer. Similarly, 2 is not an integral distance from either. 3 is not, 5 is not an integral distance from either. 6 is not an integral distance from either. So 3, 4 have no point which is an integral distance away from it. So we can confirm that U and S would be one of 1 and 6 and T will be 2. So this is T, that I know for sure now. Actually, I'll put it in red so that I can confirm that. So this is T for sure. Now it's given that ant T is nearer to ant S as compared to ant U. So this one is closer, so this must be S and this must be U. Okay, so I've gotten the positions of S, T and U based on the initial positions. Okay, so let me write that down on my this. So this is S, this is T and this is U, right? Yeah, this is S, T and U. Now I have to figure out what is PQR based on the information that I have about what has happened after the movement. Okay. Now each ant will remain inside the board after the movement. Now if you consider S, okay, if S moves up, it will move off the board. It moves left, it will move off the board. If it goes down, then it will occupy a position that was the previous position of at least previous position of 3. Even if 3 moves, it will occupy the previous position of 3. So it can't move even down. So the only one position that is left for it is to move right. So S dash I know for sure, S dash is going to be this position. So S dash is going to be this position. I'll use a different color. So this is S dash for sure. Now let me go back. Let me think of what movements are possible for T. T can go left, but if it goes left, it will overlap with the paths of S and T will overlap. So it can't go left. It can go right and it will be on the edge. It can go down and it can't go up because otherwise it will move off the grid. So it can go either right or it can go down. Okay, these are the two things that are possible for it. Now let me consider for this what is the possibility. If it moves up, it will take the position of S, which it can't do that. If it moves right, it will come here. If it moves down, it will come here, and it can't move left. So it can either move right or it can move down. Okay, now let's consider the case for S or for 5. 5 can move up. Yes, it can move left. Yes, it can move left. It can move right. It can move right and it can move down. So all of these are possible for 5. So I will not write that down because there is like we haven't determined anything. 4 can move up, 4 can move down, 4 can move left. So that is also possible. All three cases are possible for it. So it can't move to the right because otherwise it will fall off the grid. Consider the case for U. U can move up, U can move left, it can't move down, it can move right. It can move left and it can move right. So 3 things are possible for U as such. Okay, now let's take a look at the rules as such. Each ant will remain inside the board after the movement, that we already know. Ant U, T and P are in a straight line. Distance between ant T and P is equal to the distance between ant P and U. So that means that the straight line is such that this is U, this is P and this is T. That is P is midway between T and U. Now if T starts from here, T and U are over here, we have to figure out which point can be such that it is midway between T and U, okay, after movements. Only 2 ants are at the border of 6 and 6, so that and Q is one among them. ant R moved opposite to the direction of ant Q. So we don't know which is Q, so we don't know which direction Q moved in, we don't know which direction ant R moved in. Paths of no two ants will cross each other, no ant will occupy the previous position of this. So the only thing we really have to work on is the fact that U, P, T form a straight line. Now we have U has 3 directions, but T has 2 directions. So we can consider T's 2 directions and then try to figure out what could be point P and what could be point U. Now if T moves right, let us first draw that particular case. If T moves right, what is the case? 2, 3, 4, 5, 6, 7. Okay, so if T moves right, the new position is over here. If T moves right, then U cannot move right, because then the midpoint would be over here, and this guy has to move either inside or up or down. So in that case, we won't have anything which is in midway between them. So if T moves right, U can't move right, so you can either move up or left. If T moves right, if U moves up, so U will be over here, T will be over here. So somebody has to come over here. I'll just point it out. If T moves over here and U moves up, then the point P has to be over here. But nothing can really reach this point by 2 movements. So if T moves to the right, then U can't move up because this point is inaccessible by any other point as such. So that case is negated. If T moves here, then that means U can't move up, U can't move right, so U has to move left. So U has to be over here. Now that means that the midpoint is over here. Who can reach this point? 4 can reach this point. So essentially we get the case that this is T, this is U, this is P. So let me write that down. This is T, this is P, and this is U. Okay, this is the case that I have gotten as for now. I know that S dash is over here. So this S dash essentially means the new position, as in the S and T and U refer to the old position, S dash, T dash, U dash, P dash refer to the new position. Okay, so I know that S has moved over here. Now this point has moved to the point 4 has moved inside and U has moved here. So where can 5 move? See, 5 is over, 6 has moved over here, then 5 can't move down because their paths will cross while moving. Okay, paths of no two ants cross, so 5 can't move down. So essentially, this is P. If this is P, then which one would be P, Q, R we have. So we need these one of 3 and 5 will be Q, the other will be R. So they have to move in opposite directions. So if 3 moves right, 5 has to move left. If 3 moves down, 5 has to move up. Okay, that is the condition. Okay, so let me check what happens. So S I have figured out, T I have figured out, P is this one which has moved inside, and U has moved over here. Now 5 can't move down, 5 can either move to the right or up or to the left. Okay, it can't move right because 3 can't move left, and Q and R are moving in opposite directions, so it has to move either up or it has to move left. So if it moves left, what is the condition? So if it moves left, it is over here and 3 is over here, and if it moves up, then 3 is over here and 5 is over here. But in that case, there won't be anything which is at the border. We have to have something, 2 ants at the border. This one has actually come in. So we need at least 1 ant to be at the border. So we have T which is at the border. We need 1 more ant in that case to be at the border. So if 5 moves up, he is inside, 3 moves down, again he is inside. So in that case, there won't be 2 ants at the border. So that case is negated. If 5 moves to the left, again 3 moves to the right, again both these ants will be in the interior. So we'll still have only 1 ant at the border. So we can't have that case. So clearly if T moves to the right, we will be negating this condition 3 where 2 ants have to be at the border, because Q and R have to move in the opposite direction, and no matter what direction, which one you assume is Q, which one you assume is R, neither of them is going to end up at the border, and Q has to be at the border as such. So the one which can end up at the border is actually 5, and 5, for it to end up at the border, it has to move down, and for it to move down, then it will be crossing the paths of U. So clearly this can't happen. So this case where T is moving to the right is negated. So I can remove this particular case. So this case is negated. Now the second case of T is that T moves down. So let's draw that one out. Okay, so you have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, so in this case, this is S dash, so S dash is over here. Okay, in this case, T moves down, so T moves over here. Okay, this is T dash. U starts from here, so it has to move. It can't go up in this case, because then T and U will occupy the same position. It can't go to the right, because it can go to the right, because then U will be here and P will be, phi will be P, and it will be this line as such. Or it can go, if it goes to the left, and then there is no one which is coming in middle as such. Phi has to move up, and no other point can come over here as such, because you can't have any point which is occupying the previous position of 5. So U can't move left when T is moving down. So U has to move right when T is moving down. So we'll have U over here. Okay. See, if U was over here, where in the original place, it couldn't move right, it couldn't move left, because then the midpoint would have been this one, which is the original position of 5, which nobody else can take. So U can't move left, U has to now move towards right. He can't move up, because he'll then be taking the same position of T. So he can't move left, he can't move down, he can't move up. So only place that is left for him is to move right. So this is U dash. Now we have to find, so this will be P dash. So that means that this point 5 is P. So this point 5 is P. So we get this as P, and sorry, I'll use a different color. This is P. This, since this is the only case, right, this I'll put it in the final diagram itself, because I've negated the other case where T is moving to the right. So T has to move down, U has to move to the right. So this is U dash, and this is T dash, and this has to be P dash. Okay, so I found the positions of first and final positions of P, S, T and U. Now I need to find out the positions of Q and R. Now it is given that 2 points are at the edges. So U is at the edge after movement. Now Q is also at the edge after movement. Can this point over here, that is point 3, can point 3 reach an edge? No, see, he can go either to right or down. In either case, he can't reach an edge. So point 3 cannot be, this cannot be Q. So this point has to be Q, and this point therefore has to be R. This is R, original position of R, and this is original position of Q. Now it is given that Q after movement is also on the edge. So he is not going to go inside. So he is not going to go left. He can't go down because U dash is down, so otherwise they'll both end up occupying the same space. So the only place left for Q to go is over here. So this is Q dash. Now since Q is moving up, R has to move down. Therefore the new position of R is over here, which is R dash. Okay, so I found out the first and final positions of all of them, which is P, Q, R, S, T, U. The way I did that was I first figured out which was STU from the information that is given about the board before movement. From after movement, by using the fact that T, P, U are in a straight line, I got two scenarios. T is either moving to the right or T is moving down. Now from those scenarios, I removed the option of t moving to the right by negating that case. So t has to move down. Now that t has to move down, we get the following case. Okay, so this is the final answer that we need to answer all the questions. This is the only case possible, and from this we can answer all the questions because all questions are based on initial and final position of the ants. So let's take a look at the first question. What is the distance between ant U and ant Q after the movement of the ants? So ant U is over here and ant Q is over here after movement. So the distance between them is 4 centimeters. So the right answer is option B. Let's take a look at the next question. Which of the following pairs of ants will lie on a horizontal line after the movement? S and T are not in a horizontal line. They are, this is a diagonal of the grid. So they are not in a horizontal line. U and T, again not in a horizontal line. R and P are not in a horizontal line. And S and Q are in a horizontal line because this is S dash, this is Q dash. Therefore, the right answer is option D. Now, let's take a look at the next question. What is the ratio of the distance between the ants ST and ants UR after the movement? So, what is the distance between S and T after the movement? S and T is, this is 1 plus, so square root of 1 plus 4, so that is root 5, that is S dash T dash. And the second one is UR. U dash R dash is how much? U dash R dash is, this is U, this is R. So that is the integral distance, it is 5 centimeters. So this is 5 centimeters. So the ratio is root 5 is to 5. So that is 1 is to root 5. Okay. So the answer is 1 is to root 5, that is option A. Let's take a look at the last question. What is the distance between ant R and ant T after the movement? R dash T dash is how much? R dash T dash is equal to, this is R, this is T, so this is square root of 3 square plus 2 square, so this is equal to root 13. So the distance between ants R and T is option B, root 30. So this is how we calculate answers, how we solve this particular set. As you could see, once we drew out the diagram that was needed to answer the questions, it became very simple. Just see what is the final diagram needed to answer the questions. For this, we needed to know what was the initial position of the ants and what is the final position of the ants. Then we drew the boards that were required to reach that final board as such. So this is how we solve questions on 2D space LRs. Please make sure that you keep drawing at each phase. Do not try to visualize it mentally because you will make a mistake and it is just not worth it. A 4-question LR set deserves at least 12 minutes of your time because if you do it well, you get the right amount of, you get the marks. If you don't do it well, you don't get anything. So please make sure that you draw out every single scenario properly. Only then would you actually know what is the final answer as such. Okay, so this is how you solve 2D LR sets. Now after 2D LR sets, the kind of LR set that I expecting to come in CAT is enumeration LR set. These LR sets are my least favorite LR sets, but they have come regularly in CAT for the last 2 years. I think more than that actually. And the reason for that is because they are easy to set. They are very easy to set. They take a lot of time. They are basically they are time sinks. You can spend a lot of time solving it, like 15 minutes and all. And the chance of making an error is also very high because if you miss even a single case, your answer goes wrong. So for these specific reasons, I'm not fond of these sets at all. If I see an enumeration kind of a puzzle, I generally leave it. So I would suggest if you are struggling with solving any of the sets in a particular in DILR, if all the sets are very logically tough, then go for the enumeration puzzle because it is not going to be logically difficult. It is just going to be brute force kind of driven and it is going to take you time, but at least you will get those 4 questions right. So if you are finding solving any set difficult, go through the enumeration set, or you're finding it difficult, the other sets much more difficult than this, then go for the enumeration puzzle. Otherwise leave it for later. If you get time, get to the enumeration puzzle because this is going to take 15 minutes mostly. So if it takes 15 minutes, then it's going to affect your how many sets you're going to be able to solve in CAT. So generally because of it is time consuming, it has a high chance of error. I generally leave these kind of puzzles when it actually comes in CAT. The reason why there is a high chance of error is that most of the times you make some implicit assumptions about the possible cases. That means that you miss a few cases, and once you miss a few cases, the entire set can go wrong. So for all of these reasons, I personally don't prefer, but if you are confident and careful, then this might actually be your choice or your kind of a puzzle. So in enumeration LR, there isn't really a lot of tricks involved. There is no concept involved. You just have to figure out the cases individually. It is like brute force. You have to figure out, okay, but this is one case, this is one case, this is one case, this is one case, and you have to list down all the cases. The point is that your list should be exhaustive and complete. If you miss any case, you make a mistake. So that is the way you solve an enumeration puzzle. So let's take a look at an enumeration LR set so that you know how to solve these kind of puzzles. Consider the following set. Rinesh set a 8-digit PIN to his personal savings account, but while trying to open it, he accidentally pressed the wrong digit. As a result, the account was locked. Then he got in touch with the customer care representative and he gave him the following clues. The sum of all the 8 digits is a multiple of 10. The number formed by 3rd and 4th digit is a square of the number formed by 5th and 6th digits. The 2nd digit is half the 4th digit. The 7th digit is 1 more than the number of digits in the cube of the 6th digit. The 1st digit, which is non-zero, is either twice or thrice the 2nd digit. Okay, so this is the information that is given to me. What are the questions? The number of digits which can be uniquely determined in the PIN is sum of all the single digit natural numbers that are not. So basically you have to figure out what the PIN is. Okay, so you have to find out what are the possible cases for the PIN. Given you have to find which numbers for the PIN satisfy the given conditions as such. Least possible sum, yeah. So all of these are basically essentially hinting that there are multiple cases that are possible for the PIN, and you have to figure out what all those cases are by which satisfy the given conditions. So it's an 8-digit PIN. So first let me draw that out. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8. Sum of all digits is a multiple of 10. Okay, so the sum of all of these digits has to be a multiple of 10. Essentially, we'll leave that for now because we have no idea about any digit as such. The number formed by the 3rd and 4th digit is a square of the number formed by 5th and 6th digit. So, if say I'll say this is the A, B, C, D, E, F, G, H. Okay. Be careful, this is digits of a PIN. So if it's digits of a number, the first digit might actually, it's tricky if you say first digit etc. You don't know first digit from the left or from the right. But because this is the PIN, the first digit of the PIN will be from the left. Okay, so this is these are A, B, C, D, E, F, G, H, and this will be 1, 2, 3, 4, 5, 6, 7, 8. Okay, these are the 8 digits. So what is being said? The number formed by the 3rd and 4th digit is the square of the number formed by the 5th and 6th digit. So 10C plus D is the square of 10 E plus F, the whole square. So what does this mean? This means that okay, this is one of the conditions that is given. The third, this is second digit is half the 4th digit. So second digit is half the 4th digit means that B is equal to D by 2 or D is equal to 2B. So I'll put that over here. So this is equal to essentially 10C plus 2B. This means that this square has to be a even square because this is an even number, this is an even number. So the square value has to be an even square. We can then list out how many even squares that are there such that they are 2-digit numbers as such. Okay. The 7th digit is more than the number of digits in the cube of the 6th digit. Okay. And the first digit, which is non-zero, is either twice or thrice the second digit. Okay. Let me actually figure this out because these two conditions together kind of limit the number of values that CD and EF can take. So I have to figure out how many squares of even numbers are there which are less than that. So if you consider squares of natural number, see, be careful over here because E can be 0. So one of the things that you have to be careful is that you shouldn't think automatically it's a 2-digit square. So 2-digit square you will start from 16, but that would be a mistake because E can be 0, so 0, 4, 0, 9 are also valid square numbers. So what are the 2-digit square numbers that we have? So we have 0, 4, 0, 9, 1, 6, 2, 5, 3, 6, 4, 9, 6, 4, 8, 1, and after that you exceed the limit of being a 2-digit number, max 2 digits. So max 2 digits, these are the numbers that are possible. So EF have to be one of these possibilities. Okay. Now this square has to be an even number. So we can remove these possibilities. So it has to be either 0, 4, 1, 6, 3, 6 or 6, 4. Okay. These are the only possibilities we have for EF. Now EF is, if it is 0, 4, what is BC accordingly? BC would be 10C and D accordingly. So that would be, this is CD actually. So if this is CD, what is EF? EF would be 0, 2, 0, 4, this is 0, 6 and this is 0, 8. Now if you consider all the possibilities that possible values E can take only 0. Therefore, this value is definitely 0. The value of C, I made a mistake while speaking earlier. I was saying that EF can be 0 something, but the square value is actually CD. So the important thing to note is that C can be 0 and CD can be 0, 4 or 0, 9 as such, and we have to consider those cases as well. Now if you consider all the possible values for CD and all the possible values for EF, we see that in every possible value of EF, E is equal to 0. So we can remove and place E as 0 in that case. So what is the value of E? E is 0. Now what is the possible values of F? That is 2, 4, 6 and 8. Okay, so I'll write that down actually. So this is 2 or 4 or 6 or 8. Okay. Now corresponding to this 0, 2, 0, 4, 0, 6, 0, 8, what are the values of C and D? So I'll CD would be in that case. Corresponding to each case, I'll write down the values of C. So C would be 0 or 1 or 3 or 6. Okay, and corresponding values of D are 4, 6, 6, 4. Okay, so D can be 4, 6, 6, 4. So the way to read this is this is 0, 4, 1, 6, 3, 6, 6, 4 when values of CD are 0, 2, 0, 4, 0, 6, 0, 8. Okay, so these are the possible combinations for the digits 3, 4, 5 and 6. So I found at least some cases for 3, 4, 5, 6. Now let me consider the remaining conditions. Actually, it might make more sense to make a table out of this now, given that we have gotten a finite number of values as such. Actually I'll write down the value for B also, because B has a direct relation with D. So the second digit is half of the fourth digit. So this value of B will be how much? This will be this is 2, 3, 3, 2. Okay, so I got values for B as well. Okay, so I have used up this clue, I have used up this clue, and okay, the 7th digit is one more than the number of digits in the cube of the 6th digit. So what is the cube of the 6th digit? 2 cube would be 8, 4 cube would be 64, 6 cube will be 216 and 8 cube would be 529. So number of digits are 1, this is 2, this is 3, this is 3. So accordingly, what is the value of the 7th digit? The 7th digit is this is 2, this is 3, this is 4 and 4. So I'll replace the G also. So this is then 2, 3, 4, 4. Okay. Now I found all the values for this. Now I've used up this also. The last 5th clue is the first digit which is non-zero is either twice or thrice the second digit. So this is the possible values, there are actually two possible values. So 2 will be either 4 or 6, 3 will be either 6 or 9, and this is again 4 or 6. So we can replace A with like not 4 values but 8 possible configurations. So this is 4, 6, now this is 6, 9, 6, 9 and 4, 6. Okay, so these are now whatever 4 configurations have expanded to 8 configurations. Now corresponding to this, how do I find the last digit? By using the first clue. The sum of the digits has to add up to 10. Now for each of these 8 combinations, I have to add up each of the 8 combinations to find out what is the balancing digit, to find what would be a sum which would be closest to the multiple of 10. So actually, rather than doing that here in the last digit, because now it has become slightly congested with like 8 combinations and all, I'll rather draw a table so that it is clearer. So this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is digit 1, 2, 3, 4, 5, 6, 7, 8, and I have 8 rows as such. So 1, 2, 3, 4, 5, 6, 7. Okay, I'll try to do a better job of this. 1, 2, 3, 4, 5, 6, 7, 8. Okay, fine. Cool. So this first case is, this is 4, 6, 6, 9, 6, 9, 4, 6. Okay. The second, this is for the first 2 is 2. This is 3. This is 3. And this is 2. This is 0. This is 1. This is 3. This is 6. This is 4, 4, 6, 6, 6, 6, 4, 4. This is 0 in all cases. This is 2, 2, 4, 4, 6, 6, 8, 8. And this is 2, 2, 3, 3, 4, 4, 4, 4. So I have to find out the last digit such that the sum is a multiple of 10. So what is the sum over here? This is 4 plus 2 is 6, 10, 10, this is 0. So this is 4 plus 2 is 6, this is 10, this is 14. So I need the balancing digit to be 6. Okay, so the sum would be 20. Okay, this is 6 plus 2 is 8, 8 plus 4 is 12, 12 plus 4 is 16. Balancing digit would be 4. The sum again would be 20. This is 9, 10, 16, 20, 23. Balancing digit would be 7. So this would be 30. This is 12, 13, 13, 19, 19, 23, 26. So this would be 4 and this is 30. Now what is this over here? This is 9, 12, 18, 24, 28. So this digit would be 2 and this is 30. Now this is 12, 15, 12, 15 plus 6, 21, 27, 31, 31. So this digit will be 9 and this sum would be 40. This is 6, 12, 16, 24, 28. So this would be 2 and this would be 30. This is 8, 14, 18 plus 12. So this is 30 already. So this digit will be 0. Okay. So I found out all the possible pin values. So there are 8 pin possible such that all 5 conditions are satisfied. All 5 conditions are satisfied now. So there are 8 possible values of the pin given the conditions that are there. Okay. Now I can try to answer the questions that are given. The number of digits which can be uniquely determined in the pin is what? So if you see the table, for 1 the digits are changing, 2 digits are changing, 3, 4, 6, 7, 8 digits are changing. But for all combinations 5 has to be, the fifth digit has to be 0. So we can uniquely determine the fifth digit. So the number of digits that can be uniquely determined is 1. The fifth digit can be uniquely determined. The sum of all the single digit natural numbers which are definitely not present in the Arrhenius pin is, so we have to see which of 1, 2, 3, 4, 5, 6, 7, 8, 9 natural numbers is definitely not part of Arrhenius pin. So which of these numbers is not part of any of the pins that are possible? See, 1 is a part, 1 is over here in the third row, 2 is in the first row itself, 3 is in the this row with like 6, 3, 3, it's in the third row as well. 4 is in the first row, 5 is nowhere actually. So 5 is not present. 6th is there in the second row, 7th is there in the third row, last digit. 8th is there in the last row, 9th is there in the third last row. So all of the other digits are present except 5. So what is the sum of all the natural numbers that are not part of the pin? The sum of all natural numbers which are definitely not present in Arrhenius pin is 5, because 5 is the only number that is not present. Now let's go to the next question. The least possible sum of all the digits of the pin is, so we found the sums over here. So the two sums which are least are these 20, 20. So the least possible sum is 20. And which of the following statements is definitely true? If 6 is the first digit, then 4th is the last digit. Let's take a look. If 6 is the first digit, 4th is the last digit, it is true in this case but not in this case. So we can't say this is definitely true. So I'll remove option A. If 9 is the first digit, then 4th is the last digit. 9 is the first digit, then 4th is the last digit. It is true in this case, but in this case it is 9 and 9. So it is not true in this case. So we can't say this is definitely true. If 4 is the first digit, then 6th is the last digit. 4 is the first digit, then 6 is the last digit. True in this case, not true in this case. So 4 and 2 is the last digit in the second last row. So this is also not definitely true. If 0 is the third digit, then 4 is the fourth digit. If 0 is the third digit, then 4 is the fourth digit. This is true in both cases, this case and this case. And that is the only cases where 0 is there. So 0 is the third digit, then 4 is the fourth digit. This is definitely true. So I can say that this option D is definitely true. So the right answer is option D. So this is how you solve questions based on enumeration puzzles. As you could see, it took some time to get the 8 possible values, but once we got the values, it was pretty simple to solve. Please note here that there are some basic mistakes some students can make, which can make you miss cases. So if you miss the first two cases, that is the case of 0, 4 in the square, then you would have missed what is the least possible value, some value for the numbers that is possible. So it's very important that in enumeration puzzle, you write down all possible values and then eliminate. Even if it is like squares etc. that you have to write down all squares, then you can eliminate saying okay, this square will not satisfy. Because if you write down a filtered list, you might actually miss cases. So be very careful of doing that. So this is how we solve enumeration puzzles. As you could see, it was just brute force, did not require any real logic as such. So now let's go on to the next type of set that I expect to come. This is for DI. So one of the things that I expect to see in CAT in DI is a lot of tables, specifically tables with missing values. I feel that this is a good mixture of DI and LR. It requires some amount of LR, some amount of DI, and that is the kind of DI sets we have actually seen in CAT in recent years. So expect this kind of a set to come in actual CAT. So these, personally I really like these kind of sets because A, they are on the easier side, B, it's difficult to make a mistake. You generally get a proper answer and you will not, your accuracy will be pretty high in these kind of sets. So whenever I see a set like this, I always attempt. It kind of uses like a Sudoku like logic. So what is a Sudoku like logic? See, if whenever you are filling the rows or columns in Sudoku, how do you fill them? Whenever you are, whenever you see okay, the row is almost filled, you focus on that row because it's easier to infer those for those rows. So if out of 9 cells, say 7 cells are filled, only 2 are empty, it's easier to fill those 2 cells than, for example, in a row where only 3 cells are filled and 6 cells are empty. So always use that kind of this whenever you see a table with missing values. If a row is almost filled, focus on that row so that you get the completely fill that row, and that will help you fill the remaining entities as such. Similarly, if you see a column that is almost filled, fill that column first. Focus on the row totals and column totals, write them down so that they act as a guide for you to figure out how many elements are remaining to be placed as such. So that is how you have to do. It is a pretty simple set to solve. If you follow a methodical approach where you write down the table, you write down the column totals, you write down the row totals, and you try to solve, okay, in this row everything is filled except this particular cell. In this column everything is filled except this particular cell. If you follow that kind of a logic iteratively, you will get a proper table. If you don't get a complete table, what will happen, what will generally be the case is that you will then have to fill cases. That is to say that if you get a table with gaps, okay, you say that these values can't be uniquely determined. In that kind of a case, you have to say, okay, this value can take these 4 possible values. So you write down the this, like say 2, 4, 6 and 8 is the possible value for this particular cell, and then correspondingly write down what are the remaining values for the corresponding cells based on these set of values. The way I write down is that if there are 4 cases and the next case has to be a balancing kind of a case. So if I write this is 2, suppose it's something like that the sum has to be equal to say 10. If this sum of the row has to be equal to 10, the remaining missing value in the same row would be the essentially the complement of it. So this will be 8, 6, 4 and 2 correspondingly, and I write it down that way so that I know which case refers to which corresponding case in the other cell. So it's easier for me to write down. Now if such pairing is not possible, then I explicitly show that by showing that this is also 2, 4, 6, 8, and you write it down slightly separately, so differently, so that you know that these are not complementary cases. Because it's very, otherwise you will start thinking, okay, the 2 goes with 2, 4 goes with 4, 6 goes with 6, etc. and then you will make a mistake. Okay, so this is how you solve questions based on table with missing values. So now that you know how to solve these kind of sets, let's take a look at a actual DI set based on this. So consider the following set. The marks obtained by 4 students Aman, Bala, Chandan and Dinesh in the subject Maths, Physics, Chemistry and English is shown in the table. The maximum marks in each subject is 50. Some values are missing from the table. Okay, so this is a table. We have row totals over here, we have column totals over here, and some marks are missing. Now we have been given clues about that. The marks obtained by the students in subjects are natural numbers such that each score is a unique number. Marks obtained by the students in chemistry are in arithmetic progression with the common difference, odd common difference in the given order. So that means this will be 25 minus A, this will be 25 plus A, this is 25 plus 2A, such that A is odd. Okay, marks obtained by Dinesh are all odd numbers and his marks in physics is more than English. All the scores obtained by the students lie between 21 and 25. So this makes it 21 and 45. This makes it much easier, because if this is 25 minus A can at max be 21, then that puts a severe limit on what A can be. So A can at max be 4. So what are the odd numbers such that A is A can't be 0 because it's an odd, it has to be an odd number. So A can be either 1 or 3. It can't be 5 because then Aman's score in chemistry will be 20, which is lower than this lower bound. So A can be only 1 or 3 as such. Okay, so these values can be either 24 or 22. Okay, and this value correspondingly will be either if it is 3, so this is plus 3 would be either 26 or 28, and this value will be either 27 or 31. Okay, so these are the values that are possible for chemistry marks based on the fact that it is in arithmetic progression. So I have used up this clue, I will mark it off. Okay. Since they are distinct natural numbers, the progression can't be, A can't be 0. Also it is given that it's an odd common difference as such. Okay, are all odd numbers and physics is more than that of English. Okay, all scores obtained by students lie between 21 and 45. Marks obtained in the subject English are all prime numbers. So what are prime numbers between 21 and 45? 23 is a prime number. 23 is a prime number, 25 is not, 27 is not, 29 is a prime number, 31 is a prime number, 33 is not, 35 is not, 37 is a prime number, 39 is not, 41 is a prime number, 43 is a prime number. Yeah, so there are 6 possible prime numbers between 21 and 45. Okay, so given these 6 possible prime numbers, 4 of them are the marks that are there in English. So 4 of these marks will be 23, 29, 31, 37, 41 and 43. Marks obtained by each student in mathematics is a multiple of 5. So what are the multiples of 5 between this particular range? That is 25, 30, 35, 40 and 45. These are the marks that are possible. Since 25 is already gone, 25 is the marks in chemistry, so we can remove that. 25 can't be the marks again in English because all marks are unique numbers. So these 4 marks in mathematics have to be these 4 marks in certain order, that is 30, 35, 40 and 45. Okay. If we see the, so this is, I have considered this number as well. Okay, now let me take a look at the values again. So I have been given a row total, this column total, this row total and this row total. The one that I am most interested in as a row total is this 160, because 160 is a pretty high number. Given that the max value is 45, 160 is actually a pretty high total to try to hit, especially when you have 31 over here. So if you have 31 over here, what is the remaining value that you need to hit? 160 minus 31. So this is 129. So 129 divided by 3. So your average of the remaining 3 should be somewhere around 43. Now it's given that Dinesh obtained all odd numbers and physics is more than English and his average is 43. So what are the highest 3 odd numbers that he can have? So he can have 45, 43 and 41, and the average that he has to hit is 43. So he has to get 41, 43 and 45 in these 3 subjects. Only then will he be able to hit 160. So he has to, the remaining 3 values over here have to be 41, 43 and 45. Now the marks obtained in mathematics is a multiple of 5. So this has to be 45 and one of this should be 43 and the other should be 41. It is given that his marks in physics are more than in English. So this has to be 43 and this has to be 41. Okay, and that is possible only when this is 31. When it's 27, it's not even possible. So we can eliminate the first case. So we get the second case only as possible, which is 22, 28, 31. The case with like 23, 20, 24, 23, 24, 25, 26, 27 is impossible, because then the average would have been impossible to hit with the remaining numbers as such. So the only case we have is 22, 25, 28 and 31, and these values are 43, 45, 43 and 41. So I found all values for another actually 26 would have been the same, so it can't be that. So for that also we could have eliminated that particular case. So this is the numbers for chemistry, 22, 25, 28 and 31, and these are the numbers for Dinesh, which is 45, 43 and 41, 31 and 41. So I have used up this clue as well. There is nothing more that this clue can give me. All the scores obtained by the students lie in this range. Okay, so I have I focus on the prime numbers aspect, because now I have put up some prime numbers over here. See, the English marks are all prime numbers. So 31 is already gone, which is there in chemistry. 26, 43 is already gone, which is there in physics. So I am left with 23, 29, 37 and 41. 41 I have already placed for Dinesh. So the remaining have to be 23, 29, 37 and 41. Now 23, 29 and 37. Now if you see the values for Aman's score, total score is the other end. It is very small with just 96. Now 96 minus 22 is how much? Minus 22 is 4. So this is 74. So the average is something around is less than 25 actually. The average is is not an integer, but it has to be essentially each number has to be less than 25 for not each number, but the average is less than 25. So if this is so all his marks would be at the lower end as such. Now if any of the marks are, say if he gets 74, if he gets say 37, then he gets 37 has to be split into the remaining two fields, which is impossible to do, because if the lowest marks possible are 21 and 22 as such. 22 is also gone, so so the lowest sum otherwise possible is 21 plus 23. So the lowest sum possible of two cells now, given that this 22 is gone over here, is 44. So this value in English, this score in English cannot be 37, because then the remaining part would be another 37, which would be lower than the lowest possible sum of maths and physics. So English value over here for Aman, this value can't be 37. So it has to be either 23 or 29. 41 is already placed for Dinesh, and it can't be 37 for Aman either. So it has to be either 23 or 29. So now which of 23 and 29 can it be? Suppose it is say 29, okay. If it is 29, how much is this that is remaining? This would be 5 and 45. So in that case, I'd have to, I'd get a very thin this where I can hit it with 21 and 24 as such. So that is one possibility. So I can't place that uniquely right now, so I'll wait for that. I place 45 in the this order. One second, actually this is important, because this has to be at least 25, this has to be at least 30. That is the least value it can take, because I can't, this has to be a multiple of 5, so this has to be at least 30. If I put 35, the remaining sum would be 34, which would be impossible to hit. So, sorry, the remaining sum would be 39, which would be impossible to hit. So this value of Aman for mathematics cannot be 35 or 40. The max value it can take is 30. Now if this is 30, that means what is the sum of the remaining two parts? So this is 52. So 96 minus 52 gives me 44, and 44 is only possible with 21 and 23 as we saw. So one of these two is 21, the other is 23. Now we need a prime number for English, so English has to be 23 and this has to be 21. Now I have filled this and I have the column total, so I can fill in the remaining value. So the remaining value is 47 plus so 50, 90, 90 plus this, so this is 20, 114 minus 90, so this has to be 24. So I have filled 21, 22, 23, 24, 25, 26, all of these values have been filled. Now I have to fill the remaining values. If this is 30, this can be 35 or 40, this can be 40 or 35. Similarly, I can fill the remaining two also in any particular order as such. So as such, there is no other condition which is acting on them. Yeah, so essentially this can be either 35 or 40, and this can be 40 or 35, and this values I have already filled this column, so these values can be either what is left is 29 and 37, so this can be either 29 or 37, and 37 and 29. Important to note that 35 doesn't correspond to 29 and things like that. So these are two separate cases. So in all, this is two cases, this is two cases. There are 4 cases that are possible. So important to note that these are not 2 cases but 4 cases that I am actually writing over here. So I have actually used up all of the clues. There is nothing that I can actually further use to narrow down the list of possibilities. So this is the best I can fill the table with. Okay, now that I filled the table, let's go on to the questions. What is the maximum possible value of total marks obtained by Bala in the subject mathematics and English? So what is the sum? So he is 35 or 40 and 29 or 37. So max is when he gets 40 in mathematics and 37 in English. So that sum is 40 plus 37, that is 77. So the right answer is option B. What is the difference of total marks obtained by Aman, Bala and Chandu in maths to the total marks obtained by, what is the difference of total marks obtained by Aman, Bala and Chandu in maths to the total marks obtained by them in physics. So I know that, see, in B and C we don't know which got which, but one of them got one value and the other got other value. So this would not be, cannot be determined, we can uniquely determine. So what would be the marks in of ABC in maths? Marks of ABC in maths would be 30, 35 and 40. 35 and 40 being in some order, we don't know which one. So the marks in maths is 30 plus 35 plus 40 in some order. So this is 75 plus this, so this is 115. Sorry, 105. Okay, so this sum is 105, and in physics, what is the value? Physics I know for sure, so this is 21, 24, 26. So this is 50, this is 71. So what is the difference? 105 minus 71, so this is 34. So what is the difference of marks obtained in maths to the marks obtained in physics? That is option C, 34. What is the sum of the total marks obtained by all 4 students in English? So what is the sum of total marks? So that is 23, 29, 37, 41. We don't know which one has 29, which one has 37, but one of them has 29, the other has 37. So 23 plus 29 plus 37 plus 41 is the answer. So that is 23 plus 29 plus 37 plus 41. So this is 70, this is 60. So 60 plus 70, this is 130. Okay, that is option D. So the right answer is option D. What is the minimum aggregate percentage that Chandan could have obtained in all the subjects? So what is the, we basically have to first find out what is his min sum is, and divided by 4 to get the min aggregate percentage. So what is the min sum for Chandan? For minimum sum he should get 35 and 35 in maths and 29 in English. So that would be 35 plus 26 plus 28 plus 29. So that is 35 plus 26 plus 28 plus 29. So the sum would be, this is 61 plus this would be 90 plus this would be 118. So 118 is the minimum sum that he could have gotten, which means that divided, each mark is out of 50. So this is 118 out of 50 into 4. So 118 out of 200 marks. So in percentage terms, how much is that? This is, we take this out. So this is 59%. So what is the minimum aggregate percentage that Chandan could have obtained in all 3 subjects is 59%. That is option A. So in this way I can calculate all of the values once I got my table as such. Finding the table was pretty easy. Make sure that you draw out the table that is given on screen. It will take you like a minute to do that, but it is important that you have it down and fill in the values there, cut values whenever cases are impossible. This is untidy, so write down values in small numbers so that it's easier to cut and you have more space to this. Draw out bigger tables so you have more space to erase and you have more space to cut values that are no longer possible as such. So this is how you solve sets which are based on table with missing values. Now that you know how to solve these sets, please make sure that I have covered like 3 sets of now, which is, one is 2D LR set, enumeration set, and DI table with missing values. I'll be covering more that I expect to come. But for these 3 types of sets, please make sure that you actually go and practice them on your own. If you practice them on your own, you will get some idea of how to actually go about solving these kinds of sets. And it's important. These I feel are, there's a very good chance that they're going to come in CAT as such. So please make sure that you put in the effort to actually solve these sets. Thank you for tuning in. We'll be covering more sets in the next part of this video. We'll have a part 3 for this particular expected DI LR sets video series. Okay, so thank you for tuning in.